Hi, I'm Jamie, and I'll talk to you a little bit about today about Angle and how we're trying to make a portable version of OpenGL that runs on Vulkan. A lot of people today have given you pretty great detailed technical talks. I think this will be a bit of a change of pace and a little bit more high level. So to set the story, let me introduce to you the APIs we're dealing with. OpenGL has been around a long, long time. The first OpenGL spec came out in 1992. OpenGL ES came around in 2003. ES is sort of a simplified version of OpenGL that was mainly focused to run well on mobile devices. So it's fair to say that OpenGL is an old spec. It may be the first graphics spec that ever made it into the mainstream. It's pretty huge. It's hundreds of pages long. And last time I checked, there was 300 extensions in the OpenGL ES registry. There's separate specs for shader language, multiple versions of the shader language, and a separate spec for the Windows system integration. So it's a bit of a giant. But people kind of like it. It's been around a long time. It may be the first API that a lot of people learn when they're in school, and it's pretty much available everywhere. And almost because of its success on mobile, there's pretty much most devices have some kind of OpenGL drivers on them. And the tooling ecosystem for OpenGL is actually not bad because it's been around so long, including over the past few years, it's gotten better and better conformance tests. Now, Vulkan is sort of the new kid on the block, part of this new family of APIs, which give you more direct control over the hardware. For instance, like compare implementing a buffer to texture copy in OpenGL versus implementing a buffer to texture copy in Vulkan. In Vulkan, you just call buffer to texture copy. In OpenGL, you make like a pixel buffer and you do some read pixels. It's kind of weird. It's also, I think it's safe to say that Vulkan is an easier API to implement as a driver. So whereas in OpenGL, if you look at Angle's implementation of a draw call and all the stuff we do there, and compare that to an open source Vulkan driver, you'll probably see a lot fewer lines of code in Vulkan. A lot of the extra cost and validation that you get in OpenGL is pretty optional in Vulkan. Like there's these great Vulkan validation layers, but really when you're making a shipping application, you usually turn those off. And it gives you a lot of other ways to control performance like you've heard today and in other talks. And one of the nice things about Vulkan, I think, is that it has pretty good testing right out of the box. Like already, if you want to ship a Vulkan driver, there's conformance tests that you have to pass. And this should improve over time. But still, you know, a lot of people are turned off a bit by Vulkan. So I've heard it described as the union of all the things that graphics drivers can do, because it's sort of representing the set of all the things that you want to do on a graphics device. And you know, for a lot of people, maybe they'd use rather something a little bit higher level like OpenGL. But it's an incredibly powerful API. It can give you a lot to work with, and you know, you might be able to fit it in your pocket without cutting yourself. So Angle is a portable OpenGL implementation. It started back in about 2010 and was originally designed to help WebGL get started because people were a little bit worried about the stability of OpenGL drivers on Windows. So Angle came along and said, okay, well, we'll translate OpenGL into Direct3D. And since then, it's kind of grown and become a bit of a monster. It can run on almost any platform, and it can target like Direct3D 9, Direct3D 11, OpenGL, and now we're doing Vulkan. So yeah, as I said, its design is to make OpenGL portable. Let me give you a very high-level description of what Angle does in an API call and how it works. So I would, like many great software applications, Angle is a stack of layers. But I would say the difference between Angle and onions and ogres is that when you cut it open and look at it, it doesn't make you cry. It's pretty well organized, and it looks almost digestible. So you know, at the top level, we have the entry points, the OpenGL entry points. The entry points call into the validation layers. The validation layers check the state of the object in the state tracking layer. If that passes, it sends the calls at the context. The context also calls into the state tracking layer, which will then mutate the state, call into the backend in this, you know, Vulkan or OpenGL or D3D, and then the backend will call the driver, which may also have its own validation layers, which you enable in debug and then turn off and release. Okay, and just to give you a little bit more detail, I'll walk you through a GL buffer data call. Buffer data is sort of one of the most elementary calls you could have in OpenGL. It just literally redefines this data store of a buffer. Okay, so in this call, the main two things it does is it checks the validation and validate buffer data, and then it calls into the context in buffer data. This little enum thing is just an optimization we did, this buffer binding and buffer usage thing, where we found that calling switch on a GL enum generated some weird machine code. So by packing the enum from a zero-based offset to n, you get a better switch. Okay, so here we are in the context. It doesn't do much. It just handles the error that could be generated by the state tracking layer and buffer. And here we are in the buffer class. The first thing it does is it calls into the implementation. This is a virtual call. It will vary depending on what backend you're running. And then after that, it passes through the call. If it succeeds, it updates the state of the buffer. And then it notifies any objects that depend on the buffer state that the state has changed. So this kind of thing is important for caching validation, which is really starts the whole conversation about performance. You want to redo as few computations as possible when you're validating. And this is the Vulkan backend. So this is a simplified version of it. I've taken out all the sort of Vulkan boilerplate, which would make you really squint to try to read it on a slide. So I just wanted to show you, all this is doing is it's checking it needs to recreate the store, then it would call Vulkan, and if there's data passed in, then it would also call Vulkan to update the data. So hopefully that isn't too scary. Like hopefully you can see Angle is not a monster when it comes to understanding code. There's a few other things we do in the Vulkan backend and in our other backends that are important for performance. What we do in Vulkan is that we record all commands into secondary command buffers, and then it's only at submit time do we replay them on the GPU and add render passes. And I think as you heard in the first talk, this allows you to do things like set the load and store ops in the render pass to get performance wins, as well as do automatic layout transitions. So this will be important eventually. We also, when you're making a graphics driver, try to bundle our state updates together. So instead of having a code, a function that is 40 different if statements, like if the various pieces of state are dirty, we pack them into a bit set, and then we use a compiler intrinsics to find the 1 bits and only do the dirty state updates that we need. And there's many other little things we do. But where are we going with all this kind of stuff? Well, couldn't you use the power of Vulkan to implement an OpenGL driver in Angle? Couldn't Angle kind of subsume all of the drivers in the world and become the one true OpenGL driver? Is there any problem with that? Well, is this a really hard thing to do? Wouldn't it have like ridiculously bad performance compared to one of these great drivers that has been put together by some of the vendors that have been under development for 10 or more years? I think the answer to that question is probably yes. But there are some advantages that Angle has. So let me kind of try to convince you that maybe there's some advantages. The first #1 advantage, I think, is that Angle is open source. So if you want to report a bug in Angle, you don't need to sign an NDA or contact someone privately over email and go through this long, drawn-out process. You can file a bug in Angle, we'll complain and say, okay, you don't have enough data, we can't reproduce it. You'll go through our little triage process and we'll eventually fix it. If you're ambitious, you can even fix it yourself. And once you fix it, if it's a bug in the front end in Angle, or say you're implementing a new extension, everyone has it available to them. It doesn't have to be implemented in all the different drivers. And the second thing I would say is an advantage is that instead of running a graphics driver, you'll be running something in user space code. So imagine, maybe people have heard the conversation and how difficult it is to ship over-the-air updates on a mobile device. Well, if you have an application code, this could be vastly simplified. You can get much faster updates, much cheaper updates. Okay, so perf probably, honestly, will never be as good as a native OpenGL driver. It's just too hard to bar with all these layers that Angle adds. But maybe the story there is that if you're writing a very performance-intensive application like a really powerful game, you should just be talking Vulkan or some API like Vulkan directly. If you want to use a portable API that has been around for a long time that you're familiar with, and that doesn't require such performance, like say for a 2D application, well then maybe something like Angle would be a good fit. And of course, one huge problem with OpenGL drivers, like the reason Angle ever existed, is because there's such a fragmentation in the driver ecosystem. There'll be different bugs on different device drivers vendors. There'll be features that aren't available on some devices. If you do have something like Angle, this could potentially reduce fragmentation by an order of magnitude. So I think there's some convincing arguments that Angle would be a good solution for OpenGL, at least in some use cases. And so where we are with this, it isn't available yet. We're trying to finish GLES 2.0. My tentative thinking is that shouldn't take us too much longer. After that, we'll have some real serious work for us to do to fix performance and to get it as fast as possible. And then there's future API versions. If you are curious about following this project or you think it could be useful, you can check our website, and there'll be regular postings in our Google group, and you can even, if you're really curious, look at the bug burn down spreadsheet and see every little feature get turned on. And yeah, so thank you for your time. I know it might not be as useful if you're thinking about writing Vulkan directly, but if you are, doing a little small project, you want something an API that you're familiar with, you could consider using something like Angle to implement OpenGL. Thanks. So if anybody has any questions.
Question.
So let's say that I'm porting an OpenGL app to Vulkan, or I, for some reason, want to write an application part in OpenGL and part in Vulkan. Is Angle something that I could use to have OpenGL and Vulkan code running in one process and sharing textures and stuff, or is it, okay, is that practical?
Oh yeah, that will be eventually. They'll probably have to implement that even for our existing use cases. It's not in yet, but there are interoperability extensions, and we can pretty straightforwardly implement those.
Cool.
That's a good question.